You ever notice how some apps and websites just work? They're smooth, they don't crash, they do what you expect. Well, that's not an accident. The secret behind that is something called software testing. And today, we're going to pull back the curtain on this whole process, and I mean break it down for anyone, even if you've never seen a single line of code in your life. So here's how we're going to tackle this. First, we'll get into a really interesting idea, why you'd want to plan your tests before you even start building anything. Then we'll look at the simple rules that keep everything organized, check out the tools of the trade, and finish up with some really clever tricks for handling tricky situations. All right, let's kick things off with a philosophy that, I gotta say, might sound a little bit backward at first. It's this whole idea of planning your tests before you even write the code. It's a simple little switch that makes you think ahead in a really, really powerful way.
It sounds weird, right? I mean, it's like writing the answer key for an exam before you've even written the questions. But trust me, there's a super smart reason for this, and it is a total game changer when it comes to building software you can actually rely on.
And the answer to that question has a name. It's called test-driven development, or TDD for short. See, when you write a test first, you're forced to decide exactly what a piece of code is supposed to do. You define what success looks like from the very beginning. And that clarity, it's like having a blueprint that guides you to build the right thing in the right way from the get-go. So this whole TDD approach follows this really simple three-step rhythm. First, you write a test for a feature that doesn't exist yet. And of course, it fails. That's your red light. Step 2, you write the absolute simplest code you can think of just to make that test pass, and boom, you've got a green light. Finally, once you have that safety net of a passing test, you can go back and clean up the code. You make it neater, more efficient, without changing what it does. That's the refactor part. Think of it like tidying up your workshop after you've built something. Red, green, refactor. Over and over. Okay, so that's the big idea. But how does it work in the real world? I mean, to keep thousands of these tests from becoming a huge, disorganized mess, developers follow a few simple rules. It's kind of like how a library organizes its books, so you can always find exactly what you're looking for. And you know, the real secret to making all of this work is just consistency. If everyone follows the same patterns, the software tools can automatically find and run every single test without any help. It's that predictability that makes the whole system so incredibly efficient. And one of the simplest, most powerful rules is all about the name. Seriously, just by starting a file's name or a function's name with the word test, developers are sending a signal to their tools that says, hey, this is a test, you need to run this. It's such a tiny detail, but it makes a massive amount of automation possible. This organization goes for the folders too. All the tests live together in their own special tests folder. And here's the cool part. That folder is set up to be a mirror image of the main code. So if you're working on a feature in one folder, you know exactly where to look to find its tests. No more hunting around. Okay, so with the philosophy and the organization figured out, developers need the right tools for the job. In the world of Python programming, there are a couple of major players that are really good to know about. You can kind of think of it like this. Unit test is like the basic toolkit that comes in the trunk of a new car. You know, it's got what you need, it's reliable, it'll get the job done. But pytest, that's like the professional mechanics toolkit that you go out and buy yourself. It has all these specialized tools that make really complex jobs way, way faster and easier. And the real difference, it comes down to style. Unit test is a bit more formal. It asks you to follow a specific template to set things up. pytest, on the other hand, is much more relaxed. It lets you write tests with a lot less code, which a lot of people find faster and just plain easier to read. The big takeaway here is that there's different tools for different jobs and different tastes. All right, but what happens when the code you're trying to test depends on something really complicated? Like, what if it needs to talk to an online database or a credit card payment service? You can't just connect to the real thing every time you run a test. Well, developers have a very, very clever trick for this. This is a huge challenge. I mean, think about it. Imagine you're just testing whether a Buy Now button changes color when you click it. You don't want to actually charge a real credit card every single time you run that simple test. It would be slow, probably expensive, and definitely risky. So the solution is actually pretty cool, and it's surprisingly similar to how movies are made. Instead of using the real, complex, and maybe expensive parts of the system for every little test, developers use stunt doubles. These are stand-in pieces of code that just pretend to be the real thing. This lets the test run super fast and safely in its own little world. Now, the first kind of stunt double is called a stub.
A stub is super simple. Its only job is to provide a fixed, predictable answer whenever it's asked a question. So if your code needs to get a user's name from a database, a stub can just be programmed to always reply Jane Doe. That way the test can continue without ever having to touch the real database.
Then you have a mock. And a mock is a much smarter stunt double. It doesn't just give out a pre-written answer. Oh no. A mock also acts like a movie director, kind of watching the scene unfold. It checks if the other code talked to it, how many times it talked to it, and even what it said. The goal here isn't just to provide some data, it's to make sure the right conversation happened between the different parts.
So here's the simplest way to remember the difference. You use a stub when your test is asking, did I get the right answer? You just need a piece of information to continue. But you use a mock when your test is asking, did we have the right conversation? You need to know that your code interacted with something else in exactly the right way. So let's end with this thought. By starting with a test, you aren't just catching bugs later on down the line. You are fundamentally changing how you design things from the very beginning. You're forcing yourself to think about clarity and purpose first, which leads to software that's not just correct, but is also easier to understand, easier to change, and easier to build upon for years to come.